Hello, my name is Naseem and welcome to another video of machine learning lecture. So in last couple of videos we already talked what are the typical data form, means the training data set which we may get while training these regression machine learning models, this linear regression machine learning model. So the chances of the data set which we are getting while implementing this linear regression supervised machine learning model would be in two form. Every data point inside this data set having d-dimensional itself, x1, x12, x means 3 and xd. So it is a d-dimensional data, but at the same time if we talk about specifically this data, this is single dimensional data. So every x1 means the first row is deciding directly t1, but in case of this multi-dimensional data, all of the dimensions are contributing to decide this t1. So just for the easiness to understand the fundamental how we will use this data set for the training purpose to get to know the unknown variables into the data by using this data set to train the model, we will consider the single dimensional data only, right, the scalar values. So we already talked about it, what our machine learning models looks like. So this would be the machine learning regression model, right? The w naught we call it bias and m we call it order of the linear regression model, right? And here phi j of x is called basis function. We have a number of different basis functions, and phi of j of unknown variable x equals to x raised to the power j is the specific case for the polynomial linear regression. We already talked about it in last video. So if we go ahead and we find out what we find out, that this y means the predicted value for any unknown x dependent on w means unknown coefficient would be w of transpose. So this w, this capital W is actually a matrix of unknown coefficients, right? We will extensively talk about it in next couple of minutes. And this phi x is the again it is a matrix of basis function values, right? So the final prediction of any unknown variable which is x and w would be somewhat w transpose and the dot product of basis function, right? This is what we have as a final model. So for every unknown x, means we are using this data set, this x matrix x and the t matrix, to train some parameter. And what would be the training parameter? This w would be the training parameter. We will leverage some techniques and algorithm to decide the perfect value of w by using this training data set, this x and the t. And this training data set may be single dimension or multi-dimensional data set, right? We are having two different approaches to decide this unknown variable which is wt, right? Because in this equation the predicted value is actually dependent on new provided x. We will have some value of x, and we already decided what is basis function. So it depends on ourselves what basis functions we will use in implementing this machine learning algorithm. So what we left with is w transpose, means some matrix, some unknown variable matrix. To find out the value, the perfect value of this w, we will consume this data set, means the training data set, to decide its value. So there are two different approach to decide the perfect value of w, unknown variable. We have approach one, which is minimizing error function. We will talk about it. And the second thing is the probabilistic model. So let's discuss about the first method, which is first approach, which is minimizing error function. Let's reiterate what is the a linear regression model we are talking about. So we are talking about y for given x. We already have w, means the training coefficient, the trained coefficient, and it would be somewhat w t transpose of w matrix and dot product of basis function of this x, right? This is what we will use. So to tune the perfect value of w, we will approach error minimization technique, right? And what this technique is saying, what we have data set which is x1, x2, x3 and xn, and at the same time we have t1, t2, t3 and tn. This is the training data set we will use. So what we will do, we will use this x1 and t1, and we will try to use different values of w and on the basis of x1 and t1 and different value of w, we will find out y, and we will again uh, try to find out the difference between y, means the predicted value, and the original value of this function. So what I mean to say, we have an error function, and this error function is dependent on different values of w, and it is equals to 1 by 2. This is root mean square error function we are using. So it starts from 1, means the first data point, to n data point, because we are talking about n data point, and it would be y x w, difference between the predicted value and the t I. So what I mean to say by this, we will get a minimum error of this minimum value of this error function. We will try to use all of the possible w values, and we will find out that what is the minimum value of this function for all of the data points. So what I mean by saying so as you can see on the screen, we have different data points, which is x1 to xn, we can see as blue dots, and at the same time for each x we have y, and this y is actually the real value of t, and we wanted to find out a specific value w, where we can decide a function. The value of this function, this error function, must be as minimum as possible. So what I mean to say by this, if we zoom in and we are deciding some function, for example this red one is the function we are come up with, and we are this y for this data point, this is the t value, this is the t value, and this is the y value, because function this is y, this is what we are getting, this is the y value for this x point, right? And the difference between these two is something like this, right? This is the difference we are getting. So for each data point, if we talk about this one and this one, this is t, and this one is y, means the predictive, because this is the function, this is the predictive function, and this would be the difference between these two values. At the same time, if we come up with this point and this point, so this would be the error, right? This would be the error. So what we are doing in this function, we are getting error of these data points, all of the errors, all of the difference between the predicted value and the original value, and we are trying to use some specific values, different values of w in this function, and we will come up with the best to w, where the value of this error function is minimum as possible, right? So this is how we can use this approach of minimizing error function. There are a number of different error functions we can use, and this difference between the square values of the predicted function and the original value is the one method, one error function which we use extensively in the area of machine learning. So thank you for watching this video. In next video we will try to focus on the probabilistic model. So I hope you enjoy it. See you in next video.